Okay, so today we're going to talk about section 10.2. And so in trigonometry, you probably remember from last year that trigonometry is a lot about fractions. And so we did SOHCAHTOA, and you may remember that. Um, in sine, that's the opposite over the hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So represents the three letters for sine, usually opposite of our hypotenuse. For cosine, you can see ka and adjacent hypotenuse, and then toa, opposite over adjacent. And so we're going to be talking about the sides and angles of a right triangle in trigonometry. Um, the ratio is the fraction, of those related sides, the appropriate sides. And we can write equations, like we can use sine of an angle equals the opposite leg over the hypotenuse, and we can write an equation and solve stuff. We're going to use the word theta. That is going to be used a lot for the angles, okay? It's spelled theta like this, and so a lot of people put an F there instead of a TH. And then also, we actually have 6 trigonometric functions. So we're going to learn the other 3 this year. So we only learned 3 last year. We're going to learn the other 3 this year. And so um, if you are standing at a certain angle, okay, I always tell the story about, like, if you are thinking about your house, what color is the house across from you? Well, I have a house that's white across from me. And oftentimes people will shout out, a green. I'm like, awesome. But who's right? And the answer is we both are, because it depends where you live, depends where you're standing, who is opposite you. So the hypotenuse is stationary. It's the side across from the 90. Okay, that's true. In any right triangle, the hypotenuse is stationary. The opposite leg, though, is across the triangle from that angle. The adjacent means close. And so adjacent is the leg that is touching that angle. Okay. And so you got to know the difference between a right triangle has 2 legs. Which one is going to be the opposite, which is adjacent? Well, it depends what angle you're talking about. The opposite angle is the one side that's across from the angle. The adjacent leg is going to be the one that's right next to it. The hypotenuse is just the hypotenuse. It's across from the 90. And so we've got sine is so, cosine is ah, and then toa. And the deal is this. This year, we're going to do the reciprocals, okay? And so the reciprocal of sine is cosecant, okay? I wish it was sine and secant were reciprocals, but it's not. It's cosine and secant. And so it's going to be the cosecant is the hypotenuse over the opposite. And this is going to be the hypotenuse over the adjacent. Now, here's the cute one. Tangent's reciprocal is cotangent. So this would be the adjacent over the opposite. So these two are reciprocals of each other, and they make sense. The words are kind of the opposite of each other as well. So we will need to know those. Basically, if you can just remember the order that the words go, then that will help you as you're trying to find those measures. Or those fractions. And so if you look at this triangle here, if you stand at theta, of course, we can name the sides. This is the hypotenuse. This is the opposite leg because it's across from it. And this is the adjacent leg. And so if we write the fractions of sine, you're going to do 8/17. Always reduce and rationalize. The cosine would be 15, the adjacent over the hypotenuse. And then tangent, again, you did those 3 last year. And then the reciprocal functions would be the reciprocal of cosecant is the hypotenuse over the opposite leg, hypotenuse over the adjacent leg, and then adjacent over opposite for cotangent. So it's just the reciprocals of the 3 you learned last year, okay? Because that's the only way you can arrange things is you got 3 shapes or 3 sizes, you can put them as one way on a fraction or as its reciprocal. And so we can practice doing this from angle G's perspective. So we can stand over here. And so this would be, of course, the hypotenuse. This is the adjacent, and this is the opposite side. So to write this little table, I would do sine of G, cosine of G, and then tangent of G. And then again, sine is opposite, so 24/32. You should reduce it, okay? and you're going to get 3/5. Cosine of G would be the adjacent leg, which is 32 over 40. Okay, I'm not sure why I put 32. It should be 40 here. Probably because my numbers are so close together. I'm copying. If you reduce that, you get 4/5. And tangent would be the opposite leg, which is 24 over 32, which reduces to 7. Let's look. 3/4. Okay, so then what are the reciprocals? Sine's reciprocal is not secant, it's cosecant. So we label it CSC, cosecant of theta. And we could actually call it specifically G. It's not just theta, it's G. Equals, okay, we can write 5/3. Secant is a reciprocal of cosine, and that would be 5/4. And then cotangent of G would be just 4/3. Always reduce and rationalize your answers. The next one says, well, that was so much fun. Can you do the same triangle, but instead of standing at G, let's stand at F. And so let's write down these. And so our hypotenuse remains the same. But this is the adjacent leg now, and this is going to be the opposite leg because it's across from it now. If you move, what you're close to changes. If you live close to Culver's now and then you move, well, you're probably not close to Culver's anymore. Okay, and so who's adjacent, who's opposite changes. So let's do sine, cosine, and tangent, all of F. You have to say from what perspective are you speaking? So sine of F would be the opposite side of F, which is 32 over 40. And then adjacent would be 24 over 40. And tangent would be 32 over 24. Reduced, these are 4/5, 3/5, and 4/3. Now notice, when you move across a triangle, do you see that these two change, don't they? Okay, these two change with each other. Okay, so there's kind of some math going on here, because when you move, what's close to you is now what used to be across from you. Okay, so the opposite and the adjacent legs change. So if you're looking at the same triangle, the sine and the cosine get interchanged if you move angles within that triangle. And then also, if you do cosecant of F, secant of F, and cotangent of F, we're just going to do the reciprocals of each of these. And we get 5/4, we get 5/3, and we get 3/4. Okay, so you're just answering the question from that perspective. Again, standing at different parts of a triangle will interchange, sine and cosine will switch with each other. Okay. And tangent will be reciprocal. So there's a lot of connections that has to do with when you move, who's adjacent and who's opposite get interchanged. The hypotenuse is stable. Okay, and so what we're trying to do is practice looking at this. So if you do the Pythagorean theorem and you do 12 squared plus 5 squared equals x squared, you're going to get this to be 13. Or if you know it's a special right triangle, they said do sine of cosine and cosine of both of the two acute angles within this triangle. So if you do sine of D, and you also do cosine of D, you're going to get the sine of D to be the opposite 5/13 and cosine to be 12/13. If you do sine and cosine not of D, but you go to F, now notice you're going to get the sine of F is going to be 12/13 and then 5/13. What do you notice? These two are the same and those two are the same. Why? Because if you're standing here, this is the adjacent leg. If you're standing here, this is the adjacent leg. Okay. Depends where you're standing, and the opposite switches to the opposite one. Okay. And so we're going to talk about, hey, how do we figure out what that is? I feel like the next question to talk about would be this one right here. If you're taking the cosine of 20 degrees, that would equal the sine of what angle? I don't know. Let's draw it. If you are standing at a 20-degree angle right here, okay, that's your location. Sine of 20 degrees is going to be equal to the opposite side, which we can call A, over the hypotenuse, which we can call H, okay? Let's rewind the ship. Did I say sine or say cosine? Okay, and so let's do cosine. So let's try it again. So let's do the adjacent side, okay? And that's over, say, B. We'll call it A over B. Well, that equals the sine of what angle? Well, think about it. In a right triangle, remember the acute angles are supplementary or complementary, pardon me. So this would be 70 degrees. What if you stand at the 70-degree angle within this triangle? Do you see that if you found the cosine of the 70-degree angle, what would you have? You would also have A over B. So the cosine of 20 degrees equals, go across the triangle, the sine of its complement. So in any triangle, this is what is true. The sine of theta equals the cosine of 90 minus theta. What do you mean, woman? Well, think about this. You had like a 40-degree angle here. And you said, what is the sine of 40 degrees? Well, it's going to be A over B. Well, that equals the cosine of what? This right here would be 40 and what, 50 degrees. It'd be equal to the cosine of 50 degrees. That'd be this same measurement over this hypotenuse. And so as long as these are complements of each other, the sine of one angle equals the cosine of its complement. And you could try that on a calculator, type in sine of 40, see if it equals the cosine of 50. And they will. Okay, so the sine of one angle equals the cosine of its complement. So that's some math there. The next question would be, could sine or even cosine be ever bigger than 1? And the answer is no. Why? Because it's a leg over the hypotenuse. And will that ever be improper? No. The leg is always smaller than the hypotenuse, okay? Now, we didn't do the one up at the top. Tangent from A's perspective equals times the tangent of B's perspective equals what? Well, if you go here and say we call this is angle A, and this would be A, and if we call angle B, and then side B is across, a lot of times we do that. Angle C has side baby C across from it. So the tangent from A's perspective here would be the opposite over the adjacent. So it would be A over B. And then if you go up to B, you say, what is the tangent from B's perspective? That would be B over A, the reciprocals. And what happens? You get 1. Okay, and you could try that with like saving this one with numbers. You'd be like, let's do the tangent of D. Okay, tangent of B, D is equal to 5/12. And if you do the tangent from F's perspective in the same triangle, you get 12 over 5. If you times them together, you're going to get 1 because they are reciprocals of each other, because the opposite and adjacent are flipped when you move angles. So there's some good old math there. And then the next thing we should talk about is reference angles. When we graph angles, okay, well, sometimes we graph some massive angles. And what we want to do is to figure out how far that angle, that terminal side is from the x-axis. Okay. And you measure it either in degrees if it is in degrees, or you measure it in radians if it's in radians. So how far is that? So no matter how big you graph your angle, the question is now how far is it from the x-axis? Never the y, just the x-axis. Okay. And so you're going to subtract it from the closest x-axis. So some of the things you could do would be like from 0, or you could do 180 degrees, or you could do 360. Okay. Or if it's past that, you could do, trying to think, if we went around a couple times, 360 plus 180, that gives us 540. So like, I guess that's an option too. So the closest x-axis in degrees, or the closest x-axis in radians would be 0, pi, 2 pi. And I guess we could go bigger. We could keep adding pi. You could like, just like you can keep adding 180 here, you could get 3 pi, etc. So we won't get too fancy on that, but let's graph this. And 200 is just past 180 degrees, okay? So once you get here, how far is it from the closest x-axis? Well, the closest x-axis is here, and the closest x-axis numerically is 180 degrees. So find the distance between two locations, you minus them. Okay, and so if you minus those, you're going to say, okay, the distance it is from the x-axis is going to be 20 degrees. The reference angle, or how far it is from the x-axis, is 20 degrees. And we often put theta prime is that. So although the original theta is 200 degrees, the closest x-axis is only 20 degrees away. Right? The reference angle is always positive. Okay. And it's always acute. Okay, so it's it could actually equal 90 degrees. Okay. If you graphed a 90-degree angle and you're here, how far are you from the closest x-axis? Well, you could go here or here, and either one is 90 degrees. Okay. So less than or equal to 90 degrees, or pi over 2. Okay. So I had to correct myself on that one. Okay, here we go. The next one is going to be 370. So you go all the way around past 360 by a little bit. Okay. Well, when you're here, how far are you from the closest x-axis? What is this angle it makes with the x-axis? That angle is going to be, if this is 370, how many degrees is right here? Well, that's going to be 360. If you minus them, you're going to get 10 degrees. So that's going to be the reference angle is the distance from the closest x-axis. Kind of like wherever you are, how far are you from Quick Trip? It's never a negative dimension. Okay, it's how many miles or in feet or whatever it is you are from the closest Quick Trip or something fun. Okay, McDonald's. I guess there used to be like you're never more than 5 miles from McDonald's or something. So, 150. Right. So if you go to 150, how far are you from the x-axis? Well, the closest x-axis is 180. Okay. You wouldn't want to go back to 0. You wouldn't go to 360. The closest x-axis, if you go to 150, is 180. And if you minus those, your reference angle is 30 degrees away. Next one. Well, 6/7 pi is less than pi. Okay. How do you know? It is a fraction, smaller than 1. So here's where this is going to be. You could convert it to degrees to figure out where it actually is, but to start thinking in terms of radians is a good idea. If it's an improper fraction, it is past pi, and if it's more than 2 pi, it's more than one way around the circle. So you got to see, is it bigger than pi? Is it smaller than 1 pi? Is it bigger than 2 pi? What is it? So 6 pi over 7. Okay, so that's here. And this right here is pi. Well, if you want to minus those, you need a common denominator. So we're going to times that by 7 over 7. So if you do 7 pi over 7 minus 6 pi over 7, you get 1 pi over 7, or just pi over 7. So that is going to be how far it is from the x-axis. And you can figure out, okay, well, how many degrees is it? I don't really care. Okay. But it's going to be a small amount. Okay. It's an acute angle. And that's how far it is from the x-axis. Over here, 11 pi over 6. Notice it's improper. If it was all the way around, it'd be 12 pi over 6, because that makes 2 pi. So it's not quite all the way around a circle. It's 11 pi over 6. And so all the way around is 2 pi. We're going to take 2 pi minus 11 pi over 6. So if you minus those, you need a common denominator. So put this over 1 times by 6 over 6. You get 12 pi over 6 minus 11 pi over 6. That is pi over 6. So you just minus the location and the x-axis and see how far they are apart. So this angle here is going to be the reference angle there. Okay, the next part is, speaking of reference angles, we're going to graph big angles, and we are going to be finding the values of the triangle formed at that location. And the triangle formed is going to be formed between this terminal side and the x-axis, okay, the closest x-axis, and your theta prime is going to be this angle formed between those. And so we're going to be finding the sine, cosine, and tangent of this big angle, but frankly, we're going to focus on the triangle that's formed between that terminal ray and the closest x-axis, because then we can form a right triangle and do SOHCAHTOA. Okay, and so you're like, well, this is creepy. There's formulas right here to find the length of the radius. Are going to give you like a point. Okay, so they could tell you this point right here is like -4, -3. And you can say, well, that means this length here is -4. This length is hang on, -4, and this is -3. And we've got the legs of your triangle, but we need the hypotenuse. Okay, your legs can be directionally negative. Okay, in the third quadrant, your x coordinate and your y coordinate. So the directional measure of your legs are both negative in the third quadrant. The radius will never be negative, and to find it, you're going to do a squared. Let's just put it down here. X squared plus y squared equals the radius squared. So we're going to do -4 squared plus -3 squared equals r squared. And that is 16 plus 9. So this equals r squared. That's going to be a square 25. Your hypotenuse or your radius will always be positive. Okay. Always. And so we can do SOHCAHTOA from this perspective. Just use this angle here, the angle formed between the ray and the x-axis as your theta prime, or the theta you're going to use. Don't use the whole big angle because that's just too hard. And then you can answer the questions. Now, your steps for how to do the ones below here. Okay, you're like, step 1, plot the point. Step 2, connect it to the origin. I don't know why I have 3 zeros there. That's so silly. 0, 0. Step 3. Drop an altitude, height, to the x-axis. Not the y, the x. Okay, that's important. Step 4. Find radius. And that's where you do in parentheses x squared plus y squared equals r squared. It'll be positive, okay? And then step 5, find ratios. Okay, and you can use these if you want to, but most of the time you can just look at it, the picture. Okay, so let's draw this. So if we go to 3, 4, so we go right 3 and up 4. And then step 1, plot the point. Step 2, connect it to the origin, which is right here. Step 3, drop an altitude to the x-axis. Your angle is the reference angle. It's formed between here and the x-axis. Drop an altitude here. Axis, let's spell this right. Okay, and then we can label legs. So this right here is right 3 and up 4. So this length is 3, this length is 4. Okay, your angle's always the angle formed between that terminal side and the x-axis. And then we find the radius. We could go 3 squared and 4 squared equals x squared. So that's going to be 5. It'll always be positive, even if when you square stuff, make sure you put it in parentheses so you get it positive. And then we got to find the ratios. So we would do the sine of theta, cosine of theta, and tangent of theta. And then when we would also do the reciprocals, cosecant of theta, secant of theta, and cotangent of theta. So sine would be the opposite of this angle here. So it'd be 4/5, this would be 3/5, and this would be 4/3. And this would be just the reciprocals of each of those, 5/4, 5/3, and 3/4. Okay, so that's pretty straightforward. The next one, I'm gonna do 4 here. Why? Because they end up being a little weird. If you go, we'll go down here and we'll say, what if you go to -7, 4? Okay, so you go left 7 and up 4. Okay, connect it with the origin. Okay, step 3 is going to be label your sides. Okay, so this is left 7 and this is up 4. Okay, where is this theta is going to be here. but where's theta prime? Well, theta prime is always formed between that ray and the x-axis, so it'd be right here. We drop the altitude to the x-axis, never the y, always the x. And so we're going to call this our theta prime, and we're going to use that when we do trigonometry. Use the Pythagorean theorem, so you're going to go 4 squared plus negative 7 squared equals x squared. If you add those up, you're going to get 49 and 16, which is 65. We're going to square root it. So this is square root of 65. So this one gets a little special. So we do sine of theta, cosine. You can call it just plain theta because theta and theta prime, their answers are the same. Okay. And then tangent of theta, but we're going to use theta prime, the reference angle, the angle formed between that terminal side and the x-axis as our theta when we're doing this. So sine, cosine, and tangent. And we're going to do sine is the opposite, which is 4 over square root of 65. And we got to rationalize it. It gets real cute. Okay, so we get 4 root 65 over 65, that's sine. Cosine would be the adjacent leg, negative 7 over square root of 65, rationalize it. You get negative 7 root 65 over 65. And then you're going to get tangent, which is going to be 4 over negative 7. I don't care if you put the negative on top, middle, or bottom, but some of your ratios are going to be positive and some will be negative. When you do the reciprocal functions, you've got the cosecant of theta, the secant of theta, and the cotangent of theta. Okay, so let's watch this. You've got to flip over these things. Now be careful. You can choose this one or the unreduced. If it has a radical, go to the unreduced one and flip it over because you will not have to re-rationalize it. So the square is 65 over 4. This one here, if you flip over this, you get the square root of 65 over negative 7. And again, the negative can be top, middle, or bottom. And then this one will be negative 7 over 4. Okay. There are 2 more we should look at of this, and then we can be done with our notes for today. The first one is going to be, what if I give you something in the 3rd quadrant? Kids, or 3rd or 4th quadrant. Kids really struggle with either the 3rd or 4th quadrant. And so if I say, go to, let's do the 4th quadrant. So say that I would go, let's go to 3, negative 4. Okay, so if you go over 3 and down 4, it's here. Connected to the x-axis. Kids don't know, remember, you've got to form that with the x-axis. So drop an altitude to the x-axis. So if it was in the 3rd quadrant, like it is up here, if you draw this as your segment, you're going to drop it to the x-axis. If it's in the 2nd quadrant, you're going to plot your point and drop it to the x-axis here. So your angles are going to be here, your angle will be here, this angle will be here. Okay, so when you do SOHCAHTOA, you literally do need to know, hey, how am I going to get this to work? And so if this is 3 and then negative 4, when you do the Pythagorean theorem, you do 3 squared plus negative 4 squared equals x squared. So that's going to be 5. So if you do, like, I'll just start with sine. The sine of that angle will be negative 4 over 5. And cosine would be of theta would be 3 over 5. Okay, so be alert. You need to know when you connect it to the x-axis or to the origin, your triangle is formed by dropping in it, connecting that point with the x-axis, never the y. And your angle is between the x-axis. It's kind of like angle of depression, angle of elevation. From horizontal, is it up or is it down from the x-axis? So that may help you guys as well. The last one is going to be, if I give you a janky one, like what if I give you 0, 3? You're like, that's not even a triangle. No, it is not a triangle. And that's when you're like, you look at these formulas here. These formulas here would be, to find the radius, you would do 0 squared plus 3 squared equals x squared. So that would be 3, okay? And so to find sine, cosine, and tangent, you would do sine of theta is equal to y over x. Okay, so if you look at the formulas, you do y over r. So y over r, sorry. So it'd be 3 over r, which is 3, which is 1. you would do cosine of theta, which would be x over r, which would be 0 over 3, which is 0. Tangent would be 3 over 0. That is undefined. You would write undefined. And then when you flip these over, cosecant would still be 1. When you flip over 1, you still get 1. When you flip over 0 over 3, you get undefined. And then when you flip over tangent, you're going to flip over 3 over 0. That makes 0. So that's a lot weird. And that's something that as we go through the chapter, you guys will see a little bit more how this goes, but call this x, call this y, find the radius by doing 0 squared plus y squared, and then grab this formula here, put y over r, put y over x, put x over r, and then just do the reciprocals of those original fractions. If you flip over 3 over 3, you still have 1. If you flip over 0 over 3, it makes it undefined. And if you flip 0 over 3, you get 0. All right. Thank you so much. I hope you have a fantastic day.